Okay, everybody, here we're going to work on the topic of the prisoner's dilemma. So this builds on the chapter titled in the Thinking Strategically book. It's titled Resolving the Prisoner's Dilemma. And just so you note, I think for this section I will also move on into one of the sections in part 3 of the book, which you're supposed to be covering this week. I wanted to get the prisoner's dilemma in place just because it's crucial. It's one of the central notions of game theory, and it's something that's very common in business. So, of course, here's the trust but verify maxim, a Russian proverb. Ronald Reagan is famous for having quoted it. Looking back, we've seen simultaneous games, sequential games. And now we want to look at the situation where actions are repeated and where strategies can evolve such that players begin to cooperate with one another. Considering the prisoner's dilemma between two firms, you can examine this to determine that the firms each have a dominant strategy. It winds up putting them in an equilibrium where each makes $54,000 in profit, we'll call it. Under the cooperative arrangement, they could each make 60, but that's not going to be achieved in a one-shot prisoner's dilemma situation, given the dominant strategies to, let's say, price low between the two firms. A topic here regards the notion that private rationality, whereby we determine that a player in the game possesses a dominant strategy, is definitely rational on an individual basis. But the result is one of collective irrationality. The outcome that arises by the use of the dominant strategy by every player makes each player worse than the outcome that would arise if they had been cooperating. Our goal is to, of course, attempt to figure out a way to achieve a beneficial cooperative outcome, overcoming the incentives to cheat. This is called tacit collusion. Overt collusion, we should say, is problematic in a kind of legal climate where antitrust is predominant. Now, why does this dilemma occur? If you examine it carefully, you realize that really the interaction is such that there's no fear of punishment, and things are being done in a myopic sense. In the context of business firms, this is occurring when they have a lack of monopoly power, or we'll call it pricing power, where they lack differences in products and costs, right? So you have homogeneity. Things are very similar from one firm to another. There probably is overcapacity in this kind of market. And there are many incentives for profiting and trying to obtain more market share by cheating on any tacit agreements. In this market, typically the price sensitivity of customers is pretty high, price awareness is high, and there are low switching costs. So it's easy for a firm to win market share by getting customers to switch. So let's see if we can alter the outcome of the prisoner's dilemma. First, by looking at the issue of interaction. If the game is played repeatedly, as it would be in true business enterprise situations, we can exploit this fact of repeated play by inserting some kind of punishment mechanism for cheating. If things remain short-term or myopic, you've got to try to figure out a way to have repeated encounters taking place. And you want to introduce uncertainties. So first off, we'll do just a finite interaction. Sort of a starting point makes things a little simpler, and it's really a theoretical trick. Assume that the market relationship will last for t number of periods. We can use backward induction from the last period to the first period. See, in the tth period, there's no incentive to cooperate because there's no future loss to worry about. In the penultimate period, t minus the 1, you still have no incentive to cooperate because you know that in the tth period, no cooperation will take place. Thus, it doesn't make sense to cooperate in the t minus 1 period. All of this unravels backwards to period 1, and you have a persistent case of the playing of the dominant strategy, which is leading to a worse outcome. Under finite interaction, right, cooperation is impossible when the players know that the repeated play is fixed and known in length of time. This is what I mean by inserting some uncertainty. People might cooperate if the game length is unknown or uncertain, or perhaps too long. This unraveling process prevents the cooperation when there's a fixed and known number of periods. So maybe we should insert into this model what we call probabilistic termination. That is, the game will continue to be played with some probability p. In essence, this could be set up to be equivalent to an infinite game. And what we remember is the time value of money. The $1 next year is worth 1 over 1 plus r. That's the discount factor, times the probability that next year's profits are being made. See, the value of future is that there's a value if there is a future, times the probability that there's a future. Yet an effective interest rate we'll label as r prime, which is equal to 1 minus p plus r over p. That's us just simply identifying or working through the first bullet point under equivalency to the infinite game. Just mathematical interest rate r is the effective interest rate. Under long-term interaction, there would be no last period, so there's no rollback. So now we would use history-dependent strategies in such a case. And this is the topic of triggers. What you'll do is begin by cooperating. This will be the gentleman's agreement, we could call it. And cooperate as long as the rivals cooperate. And when you discover that there's a defection, revert to a punishment mechanism for some specified length of time, where you are non-cooperative as a reply to the first non-cooperator. The two classic strategies that get employed are called the Grimm trigger and the tit for tat. In the Grimm trigger strategy, your cooperation will take place, and then at one point a rival, let's say, deviates from cooperation. Now once that deviation has happened, you will play non-cooperatively for the rest of the game. Call it a Grimm trigger because you'll never come back and cooperate again. A tit for tat strategy is to cooperate if your rival cooperated in the recent period, and cheat if they cheated in the recent period. The tit for tat strategy is characterized as being forgiving. It has, very, very short memory. I don't look back beyond just simply the last period. It's proportional also. I react and I punish based upon the kind of deviation that takes place. It's also credible, but it lacks some deterrence capabilities. The Grimm trigger is the least forgiving. It has a very long memory. Right? You are setting things to what we could call a mean average deviation. And it actually is an adequate deterrent, but it lacks credibility. No one wants to harm themselves forever in this cheating mechanism where things are worse off for me. The tit for tat answers the question, is cooperation easy? And the Grimm trigger answers the question, is cooperation possible? Now, why would we cooperate? I have to look at the logic of cooperation. We would say that you should cooperate if the present value of cooperation is greater than the present value of defection. So under cooperation, the lower right-hand part of this matrix, firm 1 and firm 2 start off the game cooperating. $120 million in, let's say, profits split evenly between the two firms. If cooperation occurs, I earn 60 today, I earn 60 the next year, and so on, all the way to the end. Defection, somebody earns 72 now, and 54 next year, and 54 beyond that. This would be sort of the Grimm trigger result, if the other decided to never cooperate again. So in the Grimm trigger, I have sustained losses in the future periods, but those are going to be discounted. So I want to think about how much I'll profit right now from defection. How does that line up with the losses going forward in time periods t plus 1 and the following? Recall from finance and accounting that future monies should be discounted due to the time value of money. Imagine the R is the interest rate you could earn by investing $1 today. So the next year you know that the equivalent amount of money would be $1 times 1 plus R, the rate of interest you could earn. If you want $1 next year, you invest $1 divided by 1 plus R today to grow that less than $1 amount by an interest rate that generates that $1 next year. An annuity that pays $1 today and $1 every year has a net present value of 1 plus 1 over R. That's just an aside, reminding us how we utilize time value of money analysis. Furthermore, if the game is played infinitely, we use an infinite sums categorization for our analysis. This uses something called a Fibonacci equation, which generates a 1 plus 1 over R result. Now, that definition isn't too important to work out. Just realize that there's a little bit of good mathematics that underlies this result. The calculus of the Grimm trigger indicates I could cooperate forever, generating my value of 60 in an infinite number of periods. So this will be 60 plus 60 over R. The present value from defection is cooperation in that first round, getting my 72, and then earning 54 in all subsequent rounds. So I've got to take that at its limit, a discounted rate of 54 over R. And I'm solving for R. That would be what kind of rate of return is necessary for me to sustain cooperation. And we see the solution. Now there was a division, or we call it, a reversal of positions of R in terms of the greater than and less than signs. I skip a step in the calculation, but that makes sense because I have to divide both sides by 6, and I would therefore have 1 over R equals 12 over 6, right, or 2. And 1 over R is an inverse. So I'm really reversing the positions left and right of the 1 over R and the 2, of course. That makes R equal to 50%. So you note cooperation is sustained under the Grimm trigger as long as the rate of return is less than 50%. Think of it as saying, well, as long as $1 invested today does not return more than $1.50 next round. Right? If it returns more than $1.50, then it makes sense to defect. Here the payoff stream is replicated again. The tit for tat analysis indicates cooperation occurs when I would generate 60 through time, and 13 over 1 plus R is my middle result there, you see. And if I defect once, 72 is what I earn when I defect. Then I get punished by the other party under the tit for tat arrangement. I learn my lesson, having earned only 47, and then I go back to earning 60 again. Now that generates the value 12, it turns out. This is, just a little bit of algebra. And what you get is here R equal to 1/12, equal to, what again, 8.3%. It's much harder to sustain this tit for tat than the Grimm trigger. Under the tit for tat, there's a much tighter arrangement where if someone in the short run feels that they're going to generate greater than 8.3% in returns, which is very likely, then they're going to go ahead and they're going to engage in a deviation from the cooperation. Grimm trigger and tit for tat are the extremes along a scale. And the reason is that each possesses a characteristic that is good, and each has a fault. In terms of deterrence, remember, the Grimm trigger strategy is providing for us an adequate punishment. The tit for tat is actually not enough punishment. The credibility dimension indicates that the Grimm trigger strategy is just hurting the punisher too much for it to really be a credible kind of stance that we would expect a firm to take. Tit for tat is far more credible. So it's sort of a balancing of these two goals, bringing about a commandment and announcing a punishment strategy. Punish enough to deter your opponent and temper your punishment to remain credible. Robert Axelrod, famous for a text known as The Evolution of Cooperation, set up an experiment where he had prisoner's dilemma games repeated 200 times. Each player would play 200 times against a variety of other players. Economists and mathematicians and game theorists submitted their various strategies. And then there was pairwise competition of these strategies. The winner from the experiment was tit for tat. Axelrod summarized that tit for tat won because it was forgiving and nice, that it was provocable, and it was clear. He does nuance his finding by saying that tit for tat didn't always work. It's kind of hard for people to discover the meaning of tit for tat, to learn from it. So it requires a little bit of experimentation. He concluded you shouldn't be envious. You should never be the first to cheat. And basically, anyone who went into the deviation mode first lost in the competition round. And you should reciprocate your opponent's behavior, practicing cooperation when they cooperate, defection when they defect. And keep things simple. Don't be clever with this. So we see the topics of cooperation and deterrence kind of clear here, with a factor called credibility, this notion of announcing a punishment that you know will do harm to yourself, but tempering it so that you don't do too much harm. Thus you remain credible. And let's see, looking ahead, we're just going to ask how it is that we can be credible. So let's put that one up for week 6.